Today we're going to study division of rational expressions. Let us have the formal definition of division of rational expressions. If P, Q, R, and S are polynomials, where Q not equal to 0, R not equal to 0, and S not equal to 0, then the rational expression P over Q divided by another rational expression R over S is equal to P over Q times S over R. In words, to divide rational expressions, multiply the first fraction by the reciprocal of the second. And the final answer is, we multiply the numerator by numerator, becomes PS. We multiply denominator by denominator, and the answer is QR. How to divide rational expressions, and we're going to follow these 4 steps. Step 1, we write the division as the product of the first rational expression and the reciprocal of the second. Step 2, factor the numerators and denominators completely. Step 3, multiply the numerators and denominators together. Step 4, simplify by cancelling out common factors. Let's have example 1. Divide the rational expressions. Our first rational expression in the numerator is x cubed minus y cubed. All over, the denominator is 2x squared plus 2xy plus 2y squared. Divided by another rational expression, the numerator is x squared minus y squared, all over the denominator 4. Step 1 says we are going to rewrite our problem into multiplication of the first rational expression and the reciprocal of the second. So it means the first rational expression we will just copy down here, and then we will change the division into multiplication symbol, and then we take the reciprocal of the second rational expression. Look at the denominator 4, it becomes the numerator down here, while the numerator here becomes the denominator here. And step 2, we will factor the numerators and denominators completely. Our numerator in the first rational expression, x cubed minus y cubed, this is the difference of 2 cubes, so the factors are x minus y times the trinomial x squared plus xy plus y squared. If you are not familiar with the factors of these 2 cubes, please check again our video about factoring of 2 cubes. In the denominator, there is a greatest common factor of 2, so we move the common factor out. So what remains in the trinomial is now x squared plus xy plus y squared. For the second rational expression, the number 4, we can write it to be 2 times 2 over the denominator x squared minus y squared. This is difference of 2 perfect squares, and the factors are now x plus y and x minus y. For step 3 and step 4, we can combine them, and we can now proceed with the cancellation of common factors. Look at the x minus y here. We can cancel this with the x minus y down here. The trinomial x squared plus xy plus y squared, there is corresponding factor down here also, so we can now cancel both. The number 2 here can now cancel with the number 2 in the numerator of the second rational expression. We can now collect the remaining factors after cancelling respective common factors. In the numerator, it's only number 2 that remains, so we will copy that down here. In the denominator, the binomial x plus y remains, so we will just copy it here. So our final answer is 2 over the x plus y. Let's have example 2. Divide the rational expressions v minus 5 over 11 minus v divided by v squared minus 25 over v minus 11. So I wrote all the steps here. So I will apply step 1 to write again this problem, but I will change the division into multiplication and take the reciprocal of the second rational expression. So it's now here v minus 5 over 11 minus v times the v minus 11 over the v squared minus 25. And step 2, I will factor out the numerators and denominators completely. Our first rational expression, the numerator and denominator is already simplified, so we will just copy it down here. While the second rational expression, let's begin with our denominator. The v squared minus 25 is now factored out into v plus 5 times v minus 5. In the numerator, the v minus 11, we can write this as the negative of 11 minus v. We put it this way so that later we can cancel this with the 11 minus v in the denominator here. So we will now go to step 3 and the step 4, we will combine them. We will now cancel common factors. The v minus 5 can be cancelled with the v minus 5 here. The 11 minus b, we will now cancel with the 11 minus b. And when we collect the remaining terms, take note, there is a negative sign there, so we will put here minus 1 over the remaining factor in the denominator is the v plus 5. So our final answer is the negative 1 over v plus 5. Let us have example 3. We have a rational expression x squared plus 3x minus 10 all over 4x divided by a polynomial 2x squared plus 20x plus 50. The steps are here to guide me. I will begin with step 1. I will rewrite this again as the product of the first rational expression and the reciprocal of the second. So our problem now becomes the first rational expression and then times. Number 1 is now the numerator all over this polynomial. So the 2x squared plus 20x plus 50 is now in the denominator. I will go to step 2 to factor the numerators and denominators completely. The numerator x squared plus 3x minus 10 becomes the product of x plus 5 times x minus 2. And then I will just copy the 4x down here. In the second rational expression, the number 1 is there in the numerator all over. The trinomial here, there is a greatest common factor of 2. We put it outside what remains in the first term will be x squared. In the second term will be 10x. In the third term is 25. But I can see here that this x squared plus 10x plus 25 can still be factored out. So I'll do another line to copy everything and to put the factors of this trinomial into x plus 5 times x plus 5. And then I will now go to step 3 and step 4 to cancel common factors. The x plus 5, I will now cancel this with another x plus 5 here. And no other common factors that we can cancel. Let us now collect the remaining factors. In the numerator, the x minus 2 times 1, we will have the x minus 2. In the denominator, we multiply 4 times 2 becomes 8, and the x will just copy here. Also, there is the binomial x plus 5. We'll just put it down here. So our final answer is this x minus 2 over 8x times the binomial x plus 5. Example 4. Simplify first rational expression 10 plus w all over w minus 8 divided by the second rational expression 100 minus w squared all over 8 minus w. Let us invert the divisor, meaning the second fraction, and proceed to multiplication. That means the first rational expression we copy down here, times we invert this fraction. So the 8 minus w now in numerator, all over 100 minus w squared. We factor out the numerators and denominators completely, and let's do cancellation if possible. In the first rational expression, it is already simplified, so we just copy as is. This 8 minus w, we want to show that this is equal to the w minus 8, but we should write like this: the negative of the quantity w minus 8 all over, we factor out 100 minus w squared. Factors are 10 minus w times 10 plus w. Now let's do cancellation. We cancel this w minus 8, also the w minus 8. Take note, there is a negative sign outside here. Also, we cancel the 10 plus w and 10 plus w. Then we collect the remaining terms. So we have negative of 1 all over 10 minus w. This is the final answer. In some books, they simplify this further into 1 over w minus 10. That means the negative sign here is put in effect in the denominator. Example 5. Find the quotient 2y squared minus 10yz minus 48z squared all over 2y minus 1 divided by the polynomial 4y squared minus 32yz. Let's invert the divisor or the second fraction and proceed to multiplication. We can see that the value here is a polynomial, but we can show that this is a fraction, showing that the denominator is 1. So in the next step, we do like this. We copy the first rational expression multiplied by the number 1 comes in the numerator all over this 4y squared minus 32yz. Now we factor out the numerators and denominators completely and do cancellation whenever it's possible. First, in the numerator here, a common factor is the constant 2. So 2 comes out times the quantity y squared minus 5yz minus 24z squared. All over, same denominator will come, times the numerator is 1. In the denominator, common factor is 4y, times the quantity y minus 8z. We can simplify this trinomial inside the grouping symbol, and the factors are y minus 8z times y plus 3z. And then we copy the remaining values in the denominator and in this second rational expression. Now, let's do cancellation. We can cancel this y minus 8z. There is y minus 8z here. Also, we cancel the constant 2 with a constant 4. The constant 2 becomes 1 and this 4 becomes 2. Now, let's collect the remaining values. So we have in the numerator y plus 3z all over 2 times y is 2y times the binomial 2y minus 1. Example 6. Divide the first rational expression x cubed plus y cubed all over 2x squared plus 2xy plus 2y squared divided by the second rational expression x squared minus y squared all over 4. We invert the divisor or this second fraction and proceed to multiplication. First, we copy the first rational expression multiplied by, now we invert this fraction. 4 comes now in the numerator divided by x squared minus y squared. We factor out the numerators and denominators completely, and let's do cancellation later. The factors for x cubed plus y cubed are x plus y times x squared minus xy plus y squared. In the denominator, we can factor out the common value, which is 2. So 2 comes out times the quantity x squared plus xy plus y squared times, we copy the constant 4 all over the factors of x squared minus y squared. And factors are x minus y times x plus y. Now we do cancellation. We can cancel the x plus y and the x plus y here. Also, the 4 and the 2. 2 becomes 1, 4 becomes 2. Note that this trinomial cannot be cancelled out with a trinomial in the denominator because the sign of the middle term are not equal. So, we just put together the remaining values. In the numerator, we have 2 times this trinomial all over the x minus y times this trinomial here. Actually, this can be the final answer. But take note, in the denominator, we have this binomial multiply this trinomial. Notice that these are factors of a special product. When we simplify the denominator, it will be x cubed minus y cubed. Then we copy the same numerator. This is now the final answer.